Okay, hi everybody. Glad to see you here. And we'll go ahead and take a look at leisure today. I think the other three cases are pretty self-explanatory, and I just simply ask you to review them and then upload them as we looked at the use of Solver and this idea of optimization and management science, how it's applicable to a variety of different types of business problems. There is one of these four that I ask you to do something with, and that's the leisure case. It's over in pages 226 to 231 in the textbook, okay? And in terms of developing revenue management. And I want to just walk you through the text a little bit and then talk about what I'm wanting you to do with that file. Now, first of all, Leisure Airlines is running a hub and spokes airline system. In other words, you'll notice here that they have these different routes from which flights originate into two flights that originate in Newark and in Pittsburgh that then run that converge over in Charlotte, which is basically their hub, and then those passengers are fed out to Orlando or to Myrtle Beach. It's all about simply maximizing the number of passengers that you can bring in and then send out. And that's just really all it is. It's a hub and spoke system. It lets you, it's a milk run from here, from these two airports to here and then south, okay? So they have those. That's the basic idea, and this figure 5.4 is pretty much the way almost all airlines operate now. Southwest is somewhat the exception, not as much of an exception as it was at one point. Whole idea is this: is that, I may have 25 or 30 people who are leaving Newark who want to get to Myrtle Beach or want to get to Orlando. Well, it's pretty simple. I dump them here in Charlotte, and then I divide them up where they need to go. You may have a set of these passengers who want to go either to Myrtle Beach or to Orlando. Again, I am making certain that I mix enough numbers of people on each of these flights to then divide them up and send them out. It's really, that's been a tried and true approach for airlines. And you can see here the fare and the demand data for Leisure Air, okay? And the ODIFs, which is, as the authors show us, is an acronym for the Origin of Destinations Itinerary Fares, the ODIFs. You can see that we have we have ODIF 1 through 16, and you can see the origin where the flight leaves and where it arrives, okay? And you can see the fare classes that they have, different types, and then the code. So PCQ is Pittsburgh and Charlotte, PCO, the PCQ, okay? And then you've got the PMQ. So that's going to be PCQ is going to be Pittsburgh, Charlotte, and I would guess code Q is going to be, it's either going to be Orlando or Myrtle Beach. Okay, and so you can see how you have these trunks fed in and the different codes and the fares, and then the forecasted demand. Okay, so it's a revenue maximization problem and a load balancing problem at the same time. Okay, and here they give us the explanations for each of those. And so we have seats that are allocated based on reservation systems. Now, those folks who reserve seats and buy tickets, they're sources of revenue. So this case is, as the authors mentioned, is about revenue maximization. So here is the objective function. Okay. As you can see, the demand per flight, and we want to maximize the revenue from those. Then we've got constraints, and those constraints are going to be we have 4 capacity constraints and 16 demand constraints. They're the demand constraints. Okay. Then we have capacity constraints. So here's the objective function. We're going to maximize the revenue subject to these constraints in terms of demands, pardon me, in terms of capacity, and then demand. Now, the authors show us the solution here. And this is the leisure file. And here are the objective, here's the optimal objective value. And that's the maximizing the revenue. And here are the variables, and here are the values for each of them, and any reduced costs and any slack or surplus that might show up. Okay, and the authors give us verbiage about, you know, how they handle the reservations and how we work through this process of trying to utilize this hub and spoke system to the best possible way that we can. So what I want you to do is to go over into the files section, and you should get the Anderson, and you'll need to go to the files section. And I want you, and you get the Anderson text SDQ, and go over to chapter 4 and get leisure. You'll have it to do this with the other 3 cases in order to upload them. I wanted to spend a little bit of time talking about leisure, and I had some other resources there about leisure I wanted to talk about. Let's see, are they in here? No, it must be 5, excuse me. Yeah, it is 5, chapter 5. My apologies. Here's leisure. And I'm going to throw a copy out here on my desktop. And here's leisure. Okay, let's look at this, and then we'll talk about what I'm asking you to do for the problem. Okay, just to make sure it's your file and not a temporary, you want to save it to, I'm going to save it to my desktop. And I'm going to call it leisure. I'm just going to put my first and last name, Harmon, Keith. And there I am. Now, we have a solution for this. The authors, as I've told you before, the Anderson files are solution files. And what I ask you to do is take a file, take one of these solutions and tweak some of the data and tell me how things end up. So I'm going to go back over here to the modules. And here's the module for leisure. Okay. And I would insert a text box, excuse me. And you can size it up so it makes sense to you, or it's just easier to read. Let's put it like that. Now you say, okay, what I'm asking you to do is to compute the maximum value. And for leg 1, I want you to make the following changes. I want you to increase the fare by 10%, okay, and decrease the demand by 10%. All right. And then for leg number 2, I want you to decrease the fare 7% and add 11% onto the demand. Then on leg number 3, I want you to increase the fare 6% and leave no change, and the demand stays fixed. And I don't want you to do anything with leg number 4. Okay? Now, you say, well, why are you doing this? Well, this model, revenue maximization model, okay, is designed to work with immediate supply and demand issues that are created by incoming passenger reservations. This is no different than, okay, I run a restaurant, I have so many people show up at Sunday on 12:30, I've got to feed them, take their orders, get their orders started and going, get those orders prepared and delivered back to their table, etc. Well, it's not any different here because folks, and the revenue management model is one that also works with hotels, motels, resorts, any in which we have a queue, i.e. a line or a demand level that we forecast, but there are no guarantees that we'll have them. Now, I didn't change or ask you to change the demand levels, and what we're allocating to them. Okay, but you can look and see, for example, on leg 1, the Pittsburgh to Charlotte, it's got that fare class. The fare is $178. We forecast demand of 33. We allocate 33 seats. So while we're forecasting the demand, we have to allocate seats. We have to, and this forecast, as I said, in all of these cases, the work getting to the point where I have the forecast and the fare is part of a whole second course called operations research. So we're operating for the benefit that the company's done its due diligence to the best it can, and it's come up with these fares and these demand levels, and thus based on demand, an allocation for seating. And so we know as the planes depart Pittsburgh, or they depart, as they depart Pittsburgh, okay, and they're heading in, then or Philadelphia, then for all intents and purposes, we know how many seats we've got available for folks who are headed to Charlotte or folks who are headed to Myrtle Beach. This Leisure Airlines is what we would call, they run a milk run, basically. They're on the East Coast. They got a couple of feeder cities. Charlotte's the hub where you mix and max the passengers. So you have a full plane of people headed to one destination as much as, and a full plane of people headed the other one. That's why the hub and spoke system is the predominant way that airlines handle scheduling and the logistics of just moving people. So what I ask you to do here in this case is to change the demand of the fare and the demand by these corresponding percentages. Now, what's implied here is an issue or a question in terms of price elasticity. And we know that to a certain extent, people who fly, folks who buy airline tickets, are somewhat sensitive to changes in price, okay? And they do have price preferences. That's why you have business class and first class in airlines. People willing to pay a little more for the luxury of a bigger seat and the exclusivity of you're up front in the plane, all that business, versus everybody else who's out squeezed into their seats. Or the time of departure, how far out are you, or how soon are you buying. If you're buying the tickets later, typically you're going to pay more. And these are pricing. Now, because the airlines do this, we've seen the advent of people like Travelocity, etc., who will let you go out and find the cheapest fare for a flight based on your needs, when I need to leave, and then when I need to return, destination, all that kind of stuff. Okay. Now, in order to embellish on some of this, I provided you some resources here. And glad to see we got 9 of us here. It's a few more that ought to be here, but that's okay. But it's their money and their time. I'm glad they've got that kind of money to afford it. Hopefully they'll watch this. I had some sources there for you on, I talked about this low-cost airlines and how they've changed things. And I believe also down here in module 5, yes. I've got some data here that you can use to paste their destinations into Easy Map Maker. Hopefully you can open that file up and then go over to Easy Map Maker, and cut and paste them in and see where they fly, so you can get a map. This is a link that shows the Boeing 737-400 airliner. This isn't the Max that's having problems. This is a smaller version. I'll go over and take a look at it, hopefully. It's there. There it is. That gives you a sense of what the plane is like, a view of the cockpit, view of the accommodations. Pretty, standard size aircraft. I don't know how many people the thing holds, but it's got some information about its history, its capacity. So I wanted to let you see that because the authors mentioned that in the case, just so you could get a bit of a feeling of what that thing's like. And I had a couple of other resources for you over here. Logistics composite modeling, and you'll want to take a look at that. Here's a site that's really excellent, the Humanitarian Logistics Association. We're going to be moving into some logistics and queuing problems next week. And then some research studies on the data envelopment analysis. We have a case called County where we're going to see, we use a technique to develop benchmarks against which we measure multiple operations. The DEA is highly prevalent in all kinds of industries. So we'll take a look at that. But I thought it'd be interesting for you to see the modeling and certainly here's a resource about network structures. you have to think of an airline, they really are a network. And when we looked back in the textbook, that was pretty evident. When we saw the network. So we go back to our file here. And again, all I'm wanting you to do is by leg, increase or decrease the fare accordingly. Okay. And then I'm running an answer and a sensitivity report and do an answer and a sensitivity report for each of those. And if you want to run the third report, that's fine, but I want to see an answer and a sensitivity report for each of them. And I want to see new tabs for each of those. Okay. And I want to see an Excel file uploaded. Now, if you choose, upload an Excel file, I mean, that way I can see what you did and what you got done. And it's just simply a matter of these increments and decrements, or increases and decreases on the fare and on the demand. And for example, in leg one, we're assuming there's 1-to-1 price elasticity. How do I know that? Well, for every percent of fare that goes down, I have a 1% increase in the demand. On the other hand, now I have more than a 1-to-1 here elasticity. When I change the fare by 7%, the demand goes up 11%. So I could take that 11 and divide it by 7. Now, I didn't want that. Stupidity. This is going to equal. There we go. Oh, what is this? Okay, I got a custom thing. I'm going to put a number. There's the number. There you go. And I'll bold it up for you so you can see it real nice and pretty. And I can see it real nice and pretty. Now, what's happening is that for every, I get an 11% bump on demand, it goes up. When I cut fares by 7%, that's on leg number 2. Okay. And so that means that for every percentage I reduce the fare, I get a corresponding 1.57% increase in demand. So this leg 2 has a very elastic response or pricing condition. Then leg 3, we have less elasticity because we increase the price by 6%, but it doesn't change the demand. The people pay whatever you charge them. Okay, and that's on leg 3 in those flights. I could have added leg 4. I did not. Chose not to do it, but I wanted to. And that's really all you have to do. So you do a little simple math, and for them, and then label the tabs so I know what you're talking about. And in fact, you could even, I would change this from solution to original, and then you have the sensitivity report, and then you could just simply do leg by leg and generate a sensitivity report. Now, let's click, I'm going to click on data. I'll click on solver. Okay. And we see the original problem. Okay. And my maximum objective is B22. And the changing variables are I5, okay, to I20, the allocation. Okay, I'm going to change those, and they're subject to some constraints. The constraints are at the bottom here. C25 to C44 have to be equal to or less than E25 to E44. Let's look at the constraints. And those are capacities and then demands. And we took the total capacity for leg 1, and then we have the demand for each of those 16 flights or destinations. And that's what I wanted you to do. That's what I want you to do for leisure. And so then you have this sensitivity report. And I'll open Solver, back it up, and we'll click Solve. Oh, there we go. And we'll run it. And it's going to give, and I can keep the solver solution. And I'd like you to run an answer and a sensitivity report. If you want to run a limits report as well, I'm good to go as far as that goes. Okay? So that's what I'm after there, so that we see how that maximum revenue function changes as we have changing conditions in changes in the fare, the amount, and changes in demand. Assume changes in fare and assume changes in demand. And we go from a 1-to-1 elasticity, where for every percent of fare that it goes down, we have a percentage increase in demand. Here we have an even greater elasticity. When for every percentage of fare that we decrease, we get a 1.57% increase in demand. That's on leg 2. And leg 3, it's inelastic. Basically, we charge 6% more, and there's no change in the demand. So this is the revenue maximization. This is also, I want to also use this as a way to segue for us into network problems and queuing theory problems that arrive that we have to deal with in things like manufacturing facilities, retail outlets, handling logistics, supply chain problems. We're going to see that we'll be using optimization and using this tool in all of those types of problems. And so as we move on through the course, you're going to see how remarkably versatile that Solver is. And again, if you look at the 4 cases this week, we're dealing with 4 distinct problems or decisions, and it tells us that this process that we follow of optimization, of identifying, I identify my objective function. Am I trying to minimize, maximize, or do I have a target value? Then what variables need to be changed to get to the objective function? And then we subject it to constraints that we have to live with. And then we make a decision, what type of data are we dealing with? Is this or trend data? Is it linear? Is it non-linear? Or is it evolutionary? We just really don't know what we're dealing with. And the authors talk us through that. And the sensitivity reports help us in understanding how we get changes. When we change, we get dual values, how those changes occur as we change constraints or we change the variables that we're attempting to work with. And you can see the sensitivity report, and here you are. And here's each of the flights, the allocations. And do we reduce any costs? And then the objective coefficient and the allowable decrease. And you'll see some of these and the allowable increase. In this flight, we could go up if we want to maximize revenue as many as, it looks like, 85 passengers. Same thing here on this flight. And then we have an allowable decrease. So you can see it when we look at these allowable increases and decreases, okay, this gives us a sense or an understanding of, okay, as we work through these different routes, different flights, where can we really load people up? Where are we just really constrained by what we've got in terms of spacing? Of course, it's not as simple to do that with an airplane as it is if you got stuff coming down a conveyor belt, understandably. So you see, we do have some flex in terms of increases and decreases on those coefficients. Those are the prices, excuse me. Then we see over here the right-hand side versus the left-hand side and the shadow pricing. So for each additional unit for that leg 3 LHS flight, we're looking at we're looking at a shadow price of $179. That gives us some parameters to look at and to think about. The shadow price, remember, is also known as the dual value. So that's pretty much it in terms of leisure, in terms of what I want you to do. Now, again, I've spoken at great length about the versatility of this, and just by way of knowing, we'll go back up here for a moment, and we're looking at Relax. Relax was the Relax Resorts. They were doing a media buy. And I think we started at 156. And we talked about that media selection and the exposure quality units that we get given particular types of media that we can make buys with, and the cost per advertisement, the maximum times a month we can run them, because other people want to sell their stuff too. And we saw how we built the constraints. And our advertising program and how we built that. We also looked at Welty. So we've dealt with a marketing media buy. And Welty, I think it starts over on 162, yeah. And this is a portfolio selection and developing a portfolio. And we build our objective function, the maximization, and we allocate out by type of asset. And we have a constraint that tells us how much we've got available to invest, and further constraints on what we put in particular industries. And here's the whole kit and caboodle, the maximum, the objective function, then subject to the following constraints. And then we see the solution and the dual value and any slack surplus that we might have. Then we move on to another use, and that's Jander's. And I briefly touched on it. And this is a make or buy decision. It starts at page 169, goes through 173. Let's talk about this for just a moment. You should have at some point become a little familiar with Coase's theorem, C-O-A-S-E, or Coase's law, C-O-A-S-E. He is an economist who said, if a company can hire out work or some function cheaper than it can do it internally, it will get rid of its internal unit and it will purchase the services of a vendor. Okay? And so this idea here in terms of a make or buy is, okay, this company, Jander's, do we make what we need or do we just buy it from a vendor? Now, there are strategic issues involved in that. Obviously, if you're afraid that the vendor is unreliable, you may have to pony up and build what you have to. And if you think the vendor is reliable, then you're good. You can let them supply you things. And again, this becomes a matter of us trying to balance out what do we get if we purchase versus what we make. What does it cost us? And so as we walk through this, and they build, there's the objective function. Now this is a cost minimization problem. Okay. And then here are the constraints. And these are demand constraints. Then we have some constraints in terms of manufacturing capacity, like overtime. And then we get the result, and we see the variable, the value, the reduced cost that we achieve by doing that, and then any slack or surplus that we have, and the dual value associated with it. And we can see then the allowable increases, the allowable decreases. But the key point is we're using this optimization tool to help us make a decision on a make or buy. Now, I'm going to go into the Anderson files. Now, I believe Jander's is in chapter 4. I could be wrong. Oh, here they are. Okay. And let's take a look at it. Here we have the components. And one of the reasons I would like you to see this in Excel is because it helps summarize the verbiage that's in the textbook. Now, the authors do a great job of walking you through the process of showing you the maximum, showing you the math and for the maximum function, the constraints, the Boolean logic, etc. They provide some data. But the Excel sheet here is really what summarizes everything for you. And it is, as a decision maker, the higher you go, the more things are going to be brought to your door like this to make a decision. So that's why you want to understand the process of optimization and understand that, you know, what have we arrived at the best decision given what we have in terms of constraints, in terms of what we want to achieve. So we can see this pretty easily here. And I think these, I guess they make calculators, and you can see the different components, how much it costs to make it versus buy it, and the manufacturing time in minutes. How much time does it take us to make the thing? The same with, I guess, the financial cartridge. And there's some kind of a technical cartridge, then the top and the tech top. And they sell two types of calculators, financial or technician. And how much overtime is required, how many hours are used or needed regular versus overtime. So there's a demand. Maybe these people make several kinds of products, or maybe they're a jobber who just does assembly. They get components shipped to them and they just assemble the stuff, and then they either distribute it, or once the stuff's assembled, they send it on to a distributor. I don't think the case gives us that much detail. But again, the figures that you see here are essentially they're summaries. And as I've said over and over, to get to this point is a course in operations research. To figure out how much this cost is going to be a component cost, okay? Then you've got the manufacturing time in minutes. And to put a price tag on that, you've got to know how much a minute your manufacturing time costs. And you have to know if this 1.0 to make the base for this thing, how does it fare versus industry? How does it benchmark out? Can you get it? Are you doing it about as fast as everybody else, or slower? Or are you assembling the bases faster? So this is a summary data of what you have. And then again, of course, you click on the data and you could pop up the solver, and there you are. And you'll notice the Boolean constraints here. We've got some equivalencies. And then we have the left-hand side constraints have to be less than or equal to another set of right-hand constraints. And we're assuming here a simplex LP, which makes sense in a manufacturing environment. And we get the minimum cost. And there's the solution. And then here's the sensitivity report. Of course, the shadow price that's alluded to is the same thing as the dual value. The text talks about that. The marginal utility of one more unit or one more hour. So you say you really pump this thing of management science and this whole idea of optimization, etc. Absolutely. I've shown you now about every type of business problem that this is a highly useful tool, because it lets you, first of all, it forces you to be disciplined in your thinking. And that is, what am I really trying to achieve? Is it my maximizing, minimizing, or do I have a target value? What are the variables that need to change? What are the constraints under which I operate? And then finally, given the kind of situation I'm in or the problem I'm dealing with, is this just a simple linear problem that I could chart out in an X and Y chart? Or is this a nonlinear problem? Or is this what we would call an evolutionary? And we're going to run into all three of those. We're going to run into the other two as we work through the course. Now, I've been going on here for a while, and I'm going to stop and ask, anybody have any questions I could try to help you with? And hopefully I've clarified some things about this last assignment. Anybody? Okay, I'm going to assume then that everybody understands what I want you to do with leisure. And you're seeing, and hopefully you'll start to get a sense of networking problems like this one, where we're taking people out of 2 cities, we fly them in, and then we fly them out to their destination with a full plane of people headed only where there, obviously. Okay. So it's a simple hubs and spokes networking problem. And then I wanted to introduce the issue of elasticity, where changing prices changes demand. If nobody has any questions, though, I'll be looking forward to see your work. Now, I want you to use each of those, okay? And I'd like you to do leg 1 and see what it looks like, then do leg 2 and see what it looks like, then do leg 3. So that means I'd like to see a solution and a sensitivity report for each of these legs, at the very least. Does that make sense to everybody? Yes? And so if you wanted with the solution, you could copy it, that tab, and put in the data as you need to. Well, we started a little bit early, about 5 or 6 minutes early, so we've gone about 47 minutes. I went over 50 minutes the other day over the time. So at this point, if you don't have any questions, I'm going to wrap this thing up and go from there. Anybody have a question? Okay. Well, folks, thank you so much. And I think I've been pretty clear on what I want in terms of leisure. It'll be interesting to see what I get. Hopefully, everybody is cued in on what we're after here. Thanks a lot, folks. Have a good one.